All right, welcome to your free GRE prep hour for October 2023. My name is Dimitri Farber, and I'm going to be talking to you about overall section timing today. We'll be pulling some problems out of our 5-pound book of GRE practice problems, and you can get that for yourself if you want some extra targeted practice. So what I specifically want to talk about is how the section timing works on the new shorter version of the test, how to pick up speed, and how to allocate your time across the different parts of that section. Then we'll get some practice on some individual problems. In the past, I've gone over some of these quant speed strategies. I'll throw that out here for a second if anyone wants to take a look, but these are some things I go over in other videos. In general, I'm not trying to say that timing and speed is everything on the test. Obviously, you want to know what you're doing, you want to know rules, and you want to know strategies. But a lot of times what we're trying to do is make sure that we are efficient enough with our time usage that we are able to stop and do a good job. And I think being fast supports being slow in a sense. And what I mean by that is a lot of times I have students saying, oh, I make so many careless errors. I solved for X and I answered Y. I found Y, but I really wanted Y plus 1. I had to do 5 times 3, and somehow I said it was 16, and I know it's not 16, whatever that is. People even tell me quite often, I got the right answer, and then I just clicked the wrong one on the computer. I just clicked the wrong answer, and I don't know why. And a lot of times that's the stress and the time pressure of the test getting to us. So you want that room to breathe and say, I'm going to do the best job I can. I'm going to answer the question they asked me. It's okay to take a moment to think. And so the more efficient you can be, the less time you waste, the fewer unnecessary steps you take, the more you can take the necessary steps, the more you can pay attention, the more you can really answer with a bit of calm. And that's my wish for everybody, is that they go into the test feeling calm and feeling masterful. Um, so let's look at, first off, just in case you haven't seen, what the timing now looks like for the test. So you're going to have 2 sections, and if you know that the GRE is adaptive, right? The second section will depend in its difficulty, but not in its length, on how you did in the first section. So your first section is 21 minutes. Your second is 26 minutes. You're going to see 2 broad categories of question types that we call quant comp and discrete quant. Quantitative comparisons are the ones where you're comparing the 2 columns, right? Which is bigger, quantity A or quantity B? And they only have 4 answers, A, B, C, D. From that perspective, they're the easiest to guess right on. You have a 1 on 4 shot right from the get-go. And if you can narrow down, you often have a 1 out of 2, maybe a 1 out of 3 shot. And that's important to keep in mind. And for that reason, we tend to ask people to go a little faster on those. Discrete quant is just our name for everything else. This can include regular, just A through E multiple choice. It can include select all that apply. It can include ones where you have to fill in the blank with your own answer. And so those are very hard to guess, but I would still fill them in rather than leaving them blank if I wasn't sure. And it also includes the data interpretation sets. If you've studied for the GRE, previously when it was a more like a 4-hour test, you might have known that there was a data interpretation set where you get a chart or table or something in both of the quant sections. And we're still updating our practice tests as of October 2023 to reflect what we're now seeing in the official materials, which it looks like, and they could change it if they want, but it looks like you're going to see a 3-question data interpretation set in the first section and not in the second section. So in the second section, you'll have 5 more minutes, but you'll have 15 questions instead of 12. 1 more quantitative comparison, 2 more discrete quant, but without that data interpretation set. So, kind of giving and taking away. So with that in mind, we have to think about how we want to break down our time. And I think that's one of the most important things you can do. Have a system of benchmarks of what you're going to do. Even if it's just as simple as, hey, there's 12 questions overall. So, in the first one, so that's like 4 questions every 7 minutes. So let me make sure I'm just roughly on that pace. Or in the second section, hey, that's 15 questions in 27 minutes. So that's, every 9 minutes I make it through about 5 questions, although that'll put me, just a minute in total behind the pace. Just something just rough to get an idea. But I think we can fine tune it because quantitative comparisons are a bit meant to be a bit faster. So your average time per question on both of these works out to about 1.75 minutes. Exactly 1.75 minutes on the first section, slightly less, just barely less on the second section. So basically 1.75 minutes. So you could certainly just allocate that and plan accordingly. But generally, I would aim for something a bit more aggressive in the first part. So especially because your chance of guessing is higher, and so it's the place where you're least worried about guessing. And at the end, running out of time means your chances of guessing aren't as strong. So for that reason, I often recommend something like this. Allocate more like 1.25 minutes to the quantitative comparisons, so that you can allocate more like 2 minutes for the discrete quant. This isn't a precise science, and you might find your own order. Maybe you find, oh no, I always finish, I can always finish the 4 quant comps in 6 minutes or 5.5 minutes or whatever it is. But just rough ideas. You're not going to be timing yourself by the second on this test anyway. You don't have the bandwidth to focus on the clock that precisely. So this would be one way to do it. The second section would look very much the same. If you want to allocate 2 minutes per discrete quant, you just have a few seconds less left less on each of the 5 quantitative comparison questions. So you can think about it as 1 more minute to do 1 more question in that second section. How hard this will be partly depends on where you landed in your adaptive section. Depending on how the first section goes, you might have missed quite a few and you get an easier section. You might have missed somewhere in the middle and gotten a moderate section, or you might have missed not very many and gotten a harder section, which means that the second section may feel like a greater challenge or a lesser challenge, depending. If you're aiming for a reasonably high score, you don't want to be in the easier second section, and you may for a higher score need to be in the harder second section if you're trying to get a very high score. So you may need to adapt to the fact that the section's getting harder, but it's slightly more time pressure at the same time, just barely, just by seconds, but it's slightly more time pressure. So if they're harder, that's something to think about. That might involve choosing a place to let go. And all of these time breakdowns here are assuming that you're going to do all the questions. You definitely want to finish. You definitely want to answer every question, but this average might include the fact that you run a little bit long on a couple questions, but then you have maybe a question that you let go. But that has to be something where you can afford that trade-off, right? If you let a question go after, say, 30 seconds that you would normally have spent 2 minutes on, you have 1.5 minutes to spend, so maybe you can run 30 seconds over on 3 questions. However, if you have a question that you run to 5 minutes on, and I see this quite often, people are spending 3, 4, 5 minutes on questions, that commits you to skipping maybe 1 or 2 other questions to make up for it. It's not worth it, especially because you'll find that generally when someone's spending 5 minutes on a question, they're missing it. Right? There are exceptions. Sometimes we just got off to a wrong start, we figured it out, we turned around, we started over again or something like that, and we end up spending 5 minutes. Still not worth the investment of time. But more often than not, when someone's running long, they're missing the question anyway, so it's a good reason not to do it. So this is one way to break it down. If you'd rather have something more even, you could allocate as much as this. You could say, hey, look, I'm going to basically spend 1:45 per question. So on section 1, you could time it exactly that way. It's still useful to have a benchmark. So you could think of it as the first 4 I do in 7 minutes instead of 5. That gives me the standard 1:45 for each of the quant comps, but then I also have to average 1:45 in the discrete quant, and that's often a little bit harder to do. This will also include your data interpretation set. On those, often the first question takes a little longer, just the way it does with, say, a reading comprehension, because you have to understand what you've been given. You're not necessarily reading the table or the chart the way you would with a reading comp, but you might take a minute to just understand what they're presenting to you. And so you might be a little slower on the first question and pick up speed elsewhere. On the second section, you can't quite afford to run to 1:45 each. It's just slightly under. And just to give a nice integer benchmark, I just added 2 minutes to quant comp and took 2 minutes off discrete quant. So you could think of it as 5 problems in 8 minutes, which is pretty close to an even time with the rest, and then 10 questions in 18 minutes for the others. And you can break those down into pieces. You might say, okay, I should have, like, let's say you're using this method for the second section. You'd say, okay, I start with 26 minutes. After 8 minutes, I'll be at 18 minutes remaining at the end. And then maybe after question 10, you'll have spent 9 of these 18 minutes. So you'll have 9 minutes remaining. and then you'd expect 9 minutes left over to do the final 5 questions. So you could break it down into chunks like that of 5 questions, or of say 4 questions on the first one. You could say, all right, I'm going to have 7 minutes for the first 4 quant comps, and then 7 minutes for the next 4 discrete quant, etc. Yeah. So question was, is the first section considered easy, medium, or hard? It's more or less medium, but what you'll find with all sections, whether they're classified as easy, medium, or hard, is they're going to have a mix of difficulties. And so even in a quote unquote easy section, you might see some questions that are fairly hard. And in a hard question, you'll certainly see a range of difficulties. And one thing that's very important about that is that the questions are all worth the same. And that could take some getting used to, even if we know that for a fact. In real life, often when I put more work into something, it's partly because there's a greater reward. And even on some tests, it works that way. On the GMAT, for instance, when you get a harder question right, it's a little more valuable of a boost. But it's also switched around, because when you miss an easier question, it's a more of a chop down. The GRE is not like that. The GRE is basically just every question within a section is worth more. So if you get a harder second section, the individual questions are all worth a little bit more. If you get an easier second section, they're all worth a little bit less. But within that section, they're all equal. And so you want to make sure that you're getting through and finishing no matter what. Like, that's one of the most important things I can tell people. I always say timing out is for amateurs, right? If you're serious enough about the GRE that you're going to pay your money and go, you must not time out. And I would never say that if I didn't think everyone could do that, right? I wouldn't say to someone, you have to run a marathon and you can't stop running. You must run the whole thing. You can't walk any of it. Maybe you can't do that. Maybe that's not safe to try to do, right? But on the GRE, the beautiful thing is anyone can finish on time. You just fill in the answer. So if you're not sure, you fill it in. You say, I don't know. And the beautiful thing about the GRE is that if you are too aggressive with that, if at the end you go, oh, whoops, I guessed on too many, I have 6 minutes left. Great, no harm. Spend your 6 minutes, go back. So ideally what you do is, as you're moving through, you're flagging the questions that you think if you had time, you might still be able to improve on. And you're not even bothering to flag a question if you literally just have no idea. Right? Imagine that it's the equivalent of a question that's in a language you don't know. You're just like, hey, this is written in Korean and I don't know Korean, right? Thankfully, you won't, quite see that on the test, but you might see something that feels like that. You might just say, no, I could have all day and I could solve this. Don't even flag those. Just guess them and move on. And no penalty for guessing. Either you get it right or you don't. So that way you can even aim to finish a bit early, and that way you can spend your time the way you want it. And I think about it the same way I think about, say, finances. If I'm not sure I'll be able to afford some expenditure, let me first spend all the money I need to spend. Let me pay my bills, let me prioritize important expenses or money I really desperately want to spend. Oh, I definitely want a birthday present from my mother or whatever it is, right? And then I look at what I have left and decide if I want to do the discretionary spending. And you can see every single question on the GRE as discretionary. In other words, there is no one question on this test that you must do. You can say no to any of them. You want to answer them, but you don't have to actually do them. You don't have to solve them. So if you've been, too aggressive, you can always go back and redo and look at some more questions. But if you haven't been aggressive enough in letting go, if you have over-invested time in questions, there's no way to go back and change that. Right? You can't unspend time that you spent. So if you end the test and you've got 3 questions remaining, there's no way to fix that. Right? Whereas if you end the section with time remaining, you don't have to actually end the section. You can go back. And so if anything, err on the side of being more aggressive, so that you finish on time, or even a bit ahead. Questions on that? So one thing I recommend is that you make this personal, right? Some people are going to feel very comfortable doing this quantitative comparison in these faster times, and that gives them more room to try to max out the others. This is especially important if you're trying for a very high score. You might need to be really efficient on that quant comp, so you have room to have a high degree of accuracy on the discrete quant. Someone who's missing a few more questions per section might be giving themselves a little bit more space to slow down on the quantitative comparison in order to have a chance, and then knowing that maybe there's a few discrete quant questions that they're going to skip entirely, right? So that's something to play with. I'm slightly less likely to have someone completely skip a quantitative comparison because often there's a way to get some case or some information, narrow it down part of the way. But that does vary from person to person. And you could also mix and match, right? So maybe in the first section, let's say you've been doing quite well. Maybe in the first section, the difficulty isn't that high yet, and you're able to go through the quantitative comparison fairly quickly in 5 minutes. But in the second section, you're getting a harder difficulty section. Then you maybe slow down on the quantitative comparison. You just have to find a way to make that time up. And that might be okay to do if data interpretation slows you down. And without data interpretation, maybe you can afford to go slightly faster. So find your own personal order, but make sure it doesn't involve, allocating 4 minutes to one question, that you're still averaging out so it's not so bad. Okay. Other questions on that stuff? So I could chatter away all day about speed. Like I said, I've done several workshops of that, so I won't do that intensively, but I'll give you a few general tips for just speeding up on both parts. Specifically for quantitative comparison, a few things that are really important, and we'll make this concrete. We're going to do some problems in a moment. First off, if there's upfront work to be done, do it. If the question just says, hey, what is X? Okay, well then just, or not what is X, but like, what's bigger, X or, X divided by 3.5 or something like that. And you could say, oh, well, is there ever a case where when you divide by it gets bigger? You just do it, right? But if the question has a couple equations that might need to be combined, if it has a figure where you can make some inferences, if it has some kind of average setup or a table, then figure out what's going on with that, figure out what you know. And it's very likely that if you don't do that, you won't get the problem right. I'd say usually when there's upfront work to do, if we don't do it, the best case scenario is that we take too long. And the maybe more common worst case scenario is that we just completely missed the problem because we didn't know what was needed. We didn't know what we were really comparing. You also want to figure out if this is a problem where you're going to test different cases or if there's a single answer. If there's a single answer, if they simply ask, the number of degrees in a hexagon versus the number of degrees in a pentagon, well, even if you don't know that one has more than the other, you might know that there is an answer to how many degrees are in a particular shape. And so you would cut D. D says it depends, right? D says that sometimes A is bigger and sometimes B is bigger, things like that. If you're going to test cases, what's really important is that, and this is like the single most important thing I can say about quantitative comparison, I think. If you can find a single case, then you know that it's either that or D. And this gets back to the idea of an obvious answer, right? An obvious answer, right? So for instance, let's go back to that one about, hey, what's bigger, X or X divided by 3.5? It might seem obvious to you that it's bigger before you divide, right? So I could say, sure, and I could test a case, right? If X is 7, then this is just 7, and this is 2, right? And 7 is bigger than 2. So what does that tell us? That A can be bigger. And if A can be bigger, then it's not the case that B is always bigger, and it's not the case that they're always equal. So it's very important to recognize is that anytime, any time I get a single case, I know I'm down to 2 answers. I've got a 50-50 already. And this is one reason I can push you on speed for quantitative comparison, because already you're at a 50-50. Either the answer is always A, right? A is always bigger, or it can vary. Now, the thing I'll add is if it seems obvious, it's probably wrong. And so if you say, oh, well, of course, dividing by 3.5 is going to make things smaller. Everything gets smaller when you chop it in pieces. You're going to be tempted to too quickly say it's got to be A, and you'll miss the question. So you might actively look, is there any way to stop A from winning? Is there any way to make these equal or to make B bigger? So ideas, how could I stop A from winning? Is there a value of X for which X is not bigger than X divided by 3.5? Yeah, negative number is one example, right? So if I say, oh, well, wait, things get smaller when you divide them, but in what direction, right? If X is -7, then when you divide by 3.5, you're going to have -2, and -2 is bigger than -7. That means the answer can't be A because A says that column A is always bigger. So I've proven answer D. I don't need any other cases, but another way I could have proven that would be 0, right? If X is 0, then both quantities are 0. 0 doesn't get any smaller or bigger when you divide by something. It's still 0, right? So that would also cross that A. You don't need both. You just need to think of one. So the idea there is sometimes there's a very, very obvious answer, and you want to assume that that's not the only answer. Could be wrong. Maybe it turns out that the quote unquote obvious answer is the only thing that can happen, but usually not, because the GRE is not easy. Right? They don't ask us questions that anyone could get right in 15 seconds. So if you get an answer in 15 seconds, you better have thought of something really clever that the rest of us are missing, right? Other things won't matter. If X is a fraction, it actually doesn't change it. If I take a half and divide it by more, then it still becomes less, right? So fraction wouldn't make a difference here. Dividing by a fraction is different, right? If I was what's bigger, 3.5 or 3.5 divided by X, then it would depend on whether X is a fraction, but in this case, it doesn't. But these things would make a difference. So we're looking for those things and then say, how could I have noticed that? In our materials, we talk about a mnemonic device zone F, where you're looking for zeros, ones, negatives, extremes, fractions, things like that. But the idea is just, you don't have to use that as a laundry list. You're simply saying, what are some different things I could try that might give me a different answer? Okay. For discrete quant, which again just means the rest of quant that's not quant comp, partly it's just, what are you looking for, right? Are they asking for the value of a particular variable? Are they asking you to find possible answers? Are you totaling something? Are you breaking something down into pieces? Is it an area or a linear measure, right? So what kind of thing do they want? Mark it, put it on your paper. So one thing I say here is set up for error avoidance, right? If I know that I need Connie's age in 2 years, then maybe I'll write C plus 2 equals on my paper. Or maybe I have a table with different time frames that I've marked the one for Connie in 2 years and put a box or circle around it and I fill it in, right? It might also just mean writing out more of my steps, not trying to do too much in my head. And the faster I can get at all these steps, the more I can afford to slow down a bit and write steps down. I also want to think about if a question is worth my time. You might look at a problem that just looks like, my gosh, it's going to take me a minute and a half even to just read and understand what they're saying. And then I have to do it. There are a few problems that when I'm looking over at a practice test, I'll tell most of my students doing this problem was a mistake. And that can sound a little, I don't know, mean or patronizing if I'm saying like, hey, I can do this, but you can't. And that's not my point. My point is rather that unless you're maxing out the section, that's not the one you want to do. Right? Because it's one that's very low yield. It takes a lot of work. And even if you're going to get all of them right, if it's the hardest one, then you'd want to save that for last. So only do it if you have time at the end. And that's a normal thing to expect. So basically, don't go into the GRE with the expectation that you're going to see number 1 and do your best at number 1 and get your answer and move on. And then see number 2 and do your best at number 2 and get the answer and move on. Go in with the expectation that every now and then you're going to see a problem and say, ooh, this doesn't look like where I want to put my time. I'm going to guess on this, and I'll only come back to it if I think I can get it later with some more time. So you can even think of it as sort of a first pass, like what do they have available? What are you offering? Right? There are some cases where we don't do that, right? If someone gives me a birthday gift, I don't say, oh, this is cool. Anything else you can give me though? Like, is this what I have to take? Right? You don't do that with a gift, right? With a job interview, I also don't do that. What other questions were you going to ask? Let me see which ones I want to answer, right? You don't do that. But on the GRE, you can think of it as a menu of choices. Yes, of course, you want to get as many as possible correct. Ideally, in a perfect world, you get all of them correct, but you don't generally need to do that. And even if you are going to do that, you might still have to do it by prioritizing your time. So for instance, sometimes I'll have a section where I have gotten all of them correct, but I still skipped 1 or 2 so that I didn't soak up my time in those. Imagine that question 7, in theory, could take me 9 minutes to do. Well, I clearly don't want to spend that. So what do? I guess on number 7, I finish, I come back, and then it controls how much time I have. I say, hey, I can torture myself about this question, and try to figure out more thoroughly. But what I'm actually going to do is give myself whatever time is remaining to do it after I've done everything else. And then, maybe I'm taking a chance. Maybe there's a risk I don't get it right. But the trade-off is that I haven't burned all my time on that at the expense of other things. So those are some just general principles we can look at. So let's try a couple sets. I'll give you a quad comp set and a discrete quant set. Everyone familiar with the answer choices for quantitative comparison? I don't know how new people are to the test. But basically we're saying if we choose A, we're saying quantity A is always greater. B, we're saying quantity B is always greater. C, we're saying they're always equal. And this is why I can get rid of answers so fast, because they're saying always. So if even one time A is bigger, then they're not always equal, right? Depends, right, would be D, or not enough info. And when I see this in a regular multiple choice test, I always worry when they just suddenly say can't be determined out of nowhere. I worry that that's a trap answer. But on the GRE, each of these choices is equally likely. So there's a 1 out of 4 chance of any of these being right on a given problem. However, whichever answer seems the most obvious is often wrong. So in cases where they are always equal, it may well look like there's more than one possibility, or it may look like A is bigger. And in cases where it depends, it may look like, of course, B is bigger, or something like that. So we always have to question that first thought at least a little bit, or try to shake it loose. Okay. But if I keep getting the same result, no matter what I do, I can't stop B from being bigger, then my best guess at that point is that it really is B. And I can only work so long at it. So at some point I might just have to make a leap of faith and hope that I'm right. Okay, so those are our answers for each of these A, B, C, D. So since we're targeting about 1.25 minutes per question, I'm going to ask you to spend 3:45 on this set. So I'll jump off the micro camera and let you focus. I'm going to give you 3:45. The goal I want you to give yourself is, I'm not even a goal, the absolute requirement I want you to place on yourself is I am going to answer all of these in 3 minutes and 45 seconds, even if that means I didn't do a great job on one. And because on the GRE you can cycle back around, it's absolutely fine to say, hey, the first one I'm not sure, I'll put down an answer. And then if I have time before the 3 minutes and 45 seconds is up, I'll come back around to it and change it. But if I don't have time to change it, then whatever answer I initially wrote down will stand. So commit to writing these 3 answers down no matter what within the 3 minutes and 45 seconds, and then improving them as time allows. Okay, we ready to start? All right, there's 3 minutes and 45 seconds. Let's see how we did. If you want to push yourself for accountability, you can private chat me your answers for these three out of A, B, D for each. Make sure they're written down though. Might also be worth thinking about which of these were the hardest. How confident do I feel in my answers? Were there ones I think I spent too much time? Did I run out of time at the end? I don't want to be an amateur, right? So if you had to just completely guess on number three because you spent a lot of time on, say, number two, how do I avoid that? How do I avoid that kind of crash? And even if it worked out, maybe you look back and say, no, but I got number two right, and I guessed correctly on number three, so no harm, no foul. Well, but will that always work out? Or maybe you say, hey, I spent extra time on two and I got it right. And when I looked at three later, I would have missed it anyway. So, again, it would have worked out. But generally speaking, the odds aren't in our favor with that extra time thing. So mostly we want to think about not doing that. And I apologize, there was the fraction bars in the second problem looked really faint. These aren't meant to be like vectors or anything like that. It's just meant to be fractions. Hopefully that was clear enough. Okay, so let's see what we can do with each of these, right? One thing I might look at on this first one is say, hey, these look awfully similar. But I've got to think about in what way they're getting compared. So what's the difference between them? And what might I do to bridge that difference? One technique, if you haven't seen it, that can be useful is to write this as if it's an inequality. And the idea is that we're saying, hey, is quantity A actually bigger than quantity B? And then anything you could do to an inequality without flipping the sign, you can do to this, right? So you can do the same thing to both sides. You can add or subtract to both sides. You could also multiply or divide by any positive numbers. Now here we don't know if any of these numbers other than, 1 are positive, but we can add or subtract without worry. Of course, we can also look at just what to do to an individual side. So here I might distribute that D. Now, before I did that, I might really quickly say, okay, basically on one, the one is inside the parentheses, and the other it's not. And so one really quick way I might expect an answer of D on this is I might say, hey, it depends on whether it matters when I put the one. It depends on whether it makes it bigger or smaller to put the one inside the parentheses. And that would be a quick way to see this. But if I distribute that D, what am I going to have? I'm going to have D cubed minus 2D squared plus D. And then I'll be asking, hey, is that bigger than D cubed minus 2D squared? And then I don't multiply it by the 1 because it's outside the parentheses, plus 1. And then the beautiful thing is, like I said, I can do anything that I could do to both sides of an inequality. And so that includes adding and subtracting things, which means I could subtract D cubed. If you're comfortable doing this in all in one go, then please do. But if you're not, you can write out the steps. I just want to prove it to everybody. And then I have this, hey, is negative 2D squared plus D greater than negative 2D squared plus 1. And what I hope that you can, if you don't already see it, train yourself to see, is that all we really care about is the D and the 1, which is what I was saying earlier. So again, I could add 2D squared to both sides. I'll just do that rather than writing it this time. I don't want to divide, right? I don't want to divide by a negative because then I end up flipping signs and other things that I don't want to worry about, but I can get rid of that. And now I'm just asking, hey, is D greater than 1? Now, if they were feeling devious, they might have told us something up top about D that narrowed it down. But here, I just don't know if D is greater than 1. So my answer here is D. I don't need to test cases. I also don't cross out D knowing there's just one answer. Here's one where I did the upfront work and I was done. And that happens sometimes. Sometimes you do the upfront work on one of these and that just gives you the answer, right? It tells you, hey, it depends on whether D is bigger than 1. And I don't know. Is D 0? Then no. Is D 5? Then yes. Is D 1? Then they're equal. Okay. So it could be anything. Answer here is D. And so looking back, I could see that sooner by either just kind of visually, rather than marking all this, I could just sort of visually say, hey, this is the same on both sides, so I'm comparing D and 1. Or even earlier, I could say, oh, look, the only difference is whether I add the 1 before I multiply by D or after. And so it depends on whether D is something that makes things larger. If D is a fraction or 0 or negative, then I don't want to multiply by 1 by D. I'll make it smaller. Whereas if D is a standard counting number past 1, or even just a fraction greater than 1, then multiplying by D is going to make the left side bigger. Okay. Questions on that? Okay. Let's look over the other two. Anyone find this the most obnoxious one of the set? I think it has the potential to be that. And again, apologies if it wasn't clear that these were fractions. I'll draw those in a little better. So these are fractions. So once again, I'm trying to see which side is bigger. I could try to eyeball it. And if the GRE were feeling nice, they might make it really obvious. For instance, what if both of the fractions in A were greater than 1 and both of the fractions in B were less than 1? Then it would be, of course, A is bigger, right? Or maybe one of them was a lot more and one of them was a little less, that kind of thing, and we could still get an idea. Here it's not so clear. I could try to find out what all these things are. I do have a square root key on my calculator. And some of these square roots you probably just know. You probably know the square root of 25. You probably don't know the square root of 23. I don't. It's a little less than 5, right? But I couldn't tell you the exact decimal, and I don't want to find out. So you could try to do this on your calculator, but that's a lot of work. And if you're trying to get through this in a minute and 15, good luck calculating, what is that, 8 different square roots and doing the division and the multiplication. You don't want to do that, right? But one really cool thing you can do is, again, if you think of this as, hey, I'm going to do the same thing to both sides, I can do anything that I would do to an inequality. Well, one of the things you could do to an inequality is square both sides. Now you have to be careful, right? Because if anything is negative, then that changes values, right? When I square, if x is greater than -3 and I square it, is it true that, x squared is greater than 9? Yes, in that case, right? But I have to be careful because when I have unknowns and I don't know whether I'm dealing with a negative or positive, that can create a problem, right? But here, I'm dealing with all positive integers anyway, right? I'm dealing with all positives. And so I can just ignore the square roots. If these numbers are larger, then the square roots are going to be larger. And if they're smaller, the square roots are going to be smaller. So I can just rewrite this problem without the square roots. And much as I like square roots, I like regular numbers better. And then I can just start making eliminations based on that, right? And I can also treat this as one big fraction instead of 2. When you have 2 fractions multiplied together, it's just everything that's getting multiplied gets put on the top, and everything that's getting divided puts on the bottom. If you were dividing, you'd flip the second fraction, right? But you'd still be able to create one big fraction. So now I can just look for cancellations. At this point, honestly, I could just do it, right? So one option would just be to say, all right, well, I know what 25 times 8 is, and I know what 10 times 15 is. And here, okay, I'd have to get a calculator for that, but I could get the idea. I could say, that's bigger, but so is the bottom. Okay, there I might want to make some cancellations. So, I mean, again, you can bust out your calculator, but I might quickly go, hey, 23 goes into 46 2 times. 34 and 51 aren't as clear, so you could definitely use your calculator for that. But if you happen to know that this is 2 times 17, and this is 3 times 17, you could use that to your advantage. You don't have to. Again, calculator's there. But it's a hassle to bring it up sometimes. So when in doubt, I'll use it, but I don't always want to use it. So then I'd end up with 3/4. Okay, so here I have 3/4, and here I have the equivalent of 4/3. If I didn't want to do this multiplication, or if it had been harder numbers, I could look for cancellations there too. For instance, I could pull a 5. So here, this is 2 5s, so I can pull one out of here and one out of here. And then I have 8/6, which is again is 4/3. But the main point is it's just more than one. So even if you just knew the top is bigger than the bottom on the left and not on the right, then you know 8 wins. So the fact that it's a square root doesn't matter. Okay. That all right? So partly we're working on speed by just not doing all the math if we don't need to. And as soon as you see that you can let some part go, as soon as you know you're done, you stop wherever that is. Okay. This is also one where you might have just said, hey, I didn't see all that. And I was trying to do, I was trying to pull out, 8 is 2 root 2 and 51. I was sitting there trying to factor that. If you're in that situation, that's a good chance to pick your best guess and move on. One thing we know the answer is not going to be here, right? We know it's not going to be D because these are numbers. There's not a possibility that it varies. It depends on, what day of the week it is or something, right? There is an answer to this problem. About which side is bigger. It doesn't depend on anything other than just us finding out. And so I could know it's not D. So if you were not sure about the math here, if it looked like more that you can do in a minute and change, and I think a lot of people would say that it would be more than they can do in a minute and change, then you have a 1 out of 3 shot. You say, hey, it's not D. So it's either A, B, or C. You have a 1 out of 3. Much better than later on in the test when you have some lengthy word problem and the answer is a fill in the blank. And if you have to guess, you could just be like, 40, right? A lot harder. So 1 out of 3 is not bad odds, all else considered. Okay. Final one, kind of sneaky. You might immediately say, oh, isosceles triangles have more than one solution. You can have either of the two pairs the same. So it'd be a quick answer of D. But if you get an answer in 10 seconds, question it. So when you have an isosceles triangle, you might know that that means two sides the same, right? And so if I knew I have sides X and Y, I could say I could have two X's and a Y or two Y's and an X. But here I'd have to think, okay, either I have two 2s or I have two 11s. And that might seem fine. Notice that in both cases, 2 or 11, A wouldn't be bigger, but this would still give us two different answers. They could be equal, right, if it were 11, or B could be larger. So that would give me an answer of D. And I would do that in 10 seconds and be wrong because this first triangle doesn't exist. If you try to draw it, if you have a side of 11, there's no way to have two sides of 2, right? They would never be able to stretch across that 11-foot canyon, so to speak, right? Especially at an angle, right? Even if they were laid flat, they just would cover 4 of the 11 feet. So I've got 2 here, 2 here. That's not a triangle. Whereas I can have a tiny third side. I just have a skinny triangle, right? I can have two sides of 11, and then it's very easy to have a 2-foot bridge between them. And this just tests our third side rule, which is that the third side of a triangle has to be greater than the difference between the two other sides and smaller than the sum. So if you have two sides of 2 and 11, the third side could be anywhere between 9 and 13. Yeah, so we would have anywhere in that range. That allows 11. It doesn't allow 2. Okay, so 2 is out. These are the same. The answer is C. Is that okay? All right. Just for kicks, let's knock out the other set pretty fast. So we won't spend a ton of time review, but I'm going to give you 6 minutes to try these out, and may run a few minutes over running through the explanations if people want to stick around for them. Okay, here we go. All right, there's our 6 minutes. I hope this was an interesting set for you. Any of these problems theoretically could be a real deal breaker, just one you just say no to. And I think certainly number 41, the first one, if you were short on time and you knew you didn't like this kind of problem that much, you might see all the words and just say, you know what, I'm gonna pick a guess and move on. And then I'll come back around to it if I have time. And that's totally okay to do. Because you might get in and say, wait, what do they want me to do? And how do I tell? Number 33 probably looks easier at first glance, twice as many zebras as lions. Okay, I could probably deal with that. But then they're talking about what could be the total and indicate all such numbers. So somehow I need a principle. I'm not supposed to actually solve this. I'm supposed to know what could be, and I don't know what could be. Maybe I got stuck there. Same thing here, could be except. And so those are some difficulty warnings, right? If they're looking at possibilities, that means 12 has 4 right answers and 1 wrong answer would be one way to think of it. That will be the answer. But the idea is that 4 of these will work and only 1 won't work. And I have to find the thing that won't work, what can't happen. In 33, I don't know how many answers there are. There has to be at least 1 for it to be an answer. I can't have it be none of them. But I don't know how many. It could be up to all of them. And the first one, there's just 1 answer, but I need a precise answer using this formula. Okay, so let's run through them really quick. I won't run too much over. I just want to make sure everyone's satisfied with the answers. Here we might think about a trade-off and try to narrow down. I might say, well, there are, in the first case, I got 4 people waiting with 6 ahead. That takes 40 minutes. Now I've got more people in my party, but I've got fewer people ahead of me. I might expect a trade-off, so I might expect it not to be too much more or less than 40. However, that doesn't tell me a whole lot since there are a couple answers that are just a little bit less than 40 and a couple answers that are a bit more than 40. It's hard to know. What might help a bit more would be to recognize that if D is the number of diners, that number is getting squared, right? Whereas the number of people in line is getting multiplied by a constant, which implies that there will be linear growth based on the number of people in the line, but exponential growth based on the size of your party. So you might expect then that if you have a larger party, that's going to cause more of a delay than having more people ahead of you within reason. So you might expect an answer more than 40. But I think in the end, we just have to do the formula. We have to say, okay, if the wait time is 40 minutes, when there are 4 diners, make this a little smaller. And I don't know what K is, it's some constant, but I know that N is the number of people in line. So I'm going to say K times, okay, there's 6 people in line. All right, so then that's 16. So I have 24 equals 6K. K is 4. Now I'll just plug that into the new version of the formula. I want to know, what do I get when I have 6 people in line? And I multiply by K times the number of people in line. So K would be 4, right? So I'm not sure I can write it like this. Okay, so that's going to be 36 plus 3 times 4. That's 48. Okay, so just applying a formula. If that's clear now, great. If it wasn't clear at the beginning, you might think about it. Is that something that if I'd slowed down a bit, I would have gotten? Or was that just way too much right now? And that's okay. It's not about whether I'd ever understand it. It's about whether it's practical for me to do within 2 minutes during this test. That's all I care about. Okay. Second one, the could be thing might not be clear. I might just try some values. So I might just try by writing it down a little ratio table, zebras, lions, monkeys. Say, okay, twice as many zebras as lions. Okay, let's just say I have 2 zebras and 1 lion. And if I have to change it, I will. If it says, there's 7 times as many lions as something else, then I'll say, okay, never mind. There's 7 lions and 14 zebras. But okay, twice as many zebras as lions, 4 times as many monkeys as zebras. Okay, so if there were 2 zebras, 4 times as many monkeys would be 8. Now, I don't know if these are the numbers. I just know these could be the numbers. So there could be 11 animals, but they didn't give me that choice, right? So it's not very helpful yet. But I'd have to recognize that I could have any multiple of this. One way to think about this is that this is an X. For every 1 lion, there are 2 zebras and 8 monkeys. But there could be any multiple of this. A quick way of seeing that would then be say, okay, whatever X is, in other words, whatever the number of lions is, I have 11 times as many animals as that. So if I have 1 lion, I have 2 zebras and 8 monkeys. If I have 2 lions, I have 4 zebras and 16 monkeys. That answer is there, so I know that's a possibility, but it would be kind of a pain to try to make a million cases. So what I might need to recognize at some point is that, oh, this is going to be a multiple of 11, and that's where totaling the ratio can be very helpful. The number of animals just has to be a multiple of 11. If I have 1 lion, I have 11 total animals. If I have 2 lions, I have 22. If I have 3 lions, I have 33. So the answer is basically 11 times the number of lions. So with that in mind, I want multiples of 11. If that wasn't really obvious, I don't think it is super obvious, you might notice looking at the answers and trying to see what you see, that 2 of them involve multiples of 7 and 3 of them involve multiples of 11. And then that may give you a clue that this is about divisibility and primes, is about multiples, along with being about ratios. Okay. Also, because they're talking about totals, it can be helpful to remember to total your ratios. Okay, look at us making good time. Last problem, you might not feel entirely sure about like what would stop something from being an integer in this case, but you can just try stuff. When x is divided by 6, the remainder is 4. And all the remainder means is that when you divide by it, this is what's left over. So the simplest thing would be to say, okay, what number when divided by 6 gives me 4 left over? Well, I know 6 plus 4 is 10, right? So 10 divided by 6 would have 1 remainder 4. What's my next one? 6 more. 16 divided by 6 will be 2 remainder 4. If you think of it, you could also have 4, because 4 divided by 6 will have 0 remainder 4. So your first number, of any type like this, when they ask for a remainder, is just the number itself. And what I mean by that is, when they say, when you divide by this, you have a remainder of that, they're just saying, hey, that 4, that's how much more than a multiple of 6 you have. So a translation, like a simpler English translation of this would just be, they're saying x is 4 more than a multiple of 6, a positive or 0 multiple. So it could be 4, 10, 16, 22, etc. So one thing I could do is just test some of these. I could say, all right, let's see if x is 4, then it could be x divided by 2 would be an integer. X divided by 3 wouldn't be. X divided by 7 wouldn't be. No, okay, none of these would be. Okay, what if x is 10? Well, same thing, right? If x is 10, x divided by 2 is an integer, but x divided by 3, 7, 11, 17 are not. So I need to look for a number that's bigger so that it can be a multiple of some of these other things, right? 16 still isn't, unfortunately, so I'd have to keep going. Oh, let's see, 22 would be my next one. Okay, 22 is a multiple of 11. So I can cross off that one. And then if I do another one, 6 more would be 28. Ooh, 28's a multiple of 7. And then if I add 6 more, that's 34. 34 is a multiple of 17. Okay. If that felt like a lot of work, or if it felt like, hey, I wouldn't have thought of some of those things, another way to get there would be to ask, why is it never a multiple of 3? And the idea is that multiples of 3, this may sound obvious, but it's something we don't often think about. Multiples of 3 come every third number. So, you've got, as you probably know, 3, 6, 9, 12, 15, 18, 21, etc. But if we're at a multiple of 6, the next multiple will be 3 away. And then another 3, right? So, after 6, you have 9 and you have 12 are multiples of 3. But if I'm 4 away, I'm between multiples of 3. All right. And that's different from any of the other numbers, because 6 isn't a multiple of 7 or 11 or 17, right? 6 is a multiple of 2 automatically, and so is 4. So all of these numbers are even, because if you take a multiple of 6, that's even, and you add 4 to it, it's still even. So every number you find will work for A. But for the rest, you need a special case where you end up with a multiple of 7 from adding 4 on to your multiple of 6. But you'll never get a multiple of 3 from adding 4 on, because 6 is a multiple of 3 and 4 isn't. So you're adding a multiple and a non-multiple, you get a non-multiple. X can't be a multiple of 3. Okay. Hope that helps on that set. Stick around if you've got questions. But the main theme I really want to push today is that we're making and sticking to a timing plan, and we're getting used to thinking about our timing and not just assuming that we're going to do every problem in the kind of generic time allotted. So the general plan that I kind of push that's a little bit more aggressive with quantitative comparison is to spend about a minute and a quarter on those. So you have 2 minutes each on the rest. If you're a little faster on discrete quant, or if you're a little bit more aggressive with skipping, you could afford to slow down on quantitative comparison a little bit and bring it closer to the same average as for discrete quant. But then you'd have to make sure that was paying off for you. Are you really getting that additional boost in accuracy on those 1 out of 4 choices, or sometimes 1 out of 3 or 1 out of 2 choices? And is it worth any loss you have on discrete quant to do that, right? So when in doubt, I would endorse this plan instead. Okay. Let me know if you have any questions. Other than that, I hope this is helpful for everybody, and I'd love to see you in one of our classes. Remember, you can come check out any of our classes, the first session for free, see what you like, see if you vibe with the teacher and the material. So we'd love to see you around. Thanks, everybody. Have a great night.